Good morning. Today I'm going to present to you a magazine that analyzes three important architectural projects. Two of them are works by Foster and Partners, one of the most renowned firms in the world, and the third is a pavilion that we developed as students. The magazine focuses on the design, the structure, foundation, sustainability, and the finishes of each project. Before looking at the projects, it is important to understand who Foster and Partners are. It is an international firm founded by Norman Foster, known for its high-tech architectural and sustainability-oriented approach. Their philosophy is doing more with less, meaning using technology and engineering to achieve efficiency without sacrificing design. They have won awards, such as the Pritzker Prize, and have built iconic works like the Miller Viaduct, the tallest cable-stayed bridge in the world. The first project is the 270 Park Avenue skyscraper, located in the heart of Manhattan. The tower reaches over 420 meters in height, making it one of the tallest buildings in New York City. It serves as the new global headquarters for JP Morgan and Chase, and it is designed to operate using 100% renewable energy, aiming for a truly zero emissions performance through its life cycle. This makes it the first major commercial skyscraper in New York City to fully commit to this level of environmental responsibility. One of the most innovative aspects of this building is the radical relocation of the structural core. Traditionally, skyscrapers place the core at the center of the building to stabilize the building and accommodate elevators, stairs, and mechanical systems. However, in 270 Park Avenue, the architects moved the entire core to one side of the tower. This design unlocks extremely large, column-free office floors, some of the largest in Manhattan, providing unmatched flexibility for tenants. The floor plates prioritize natural light, offering panoramic views and reducing the need for artificial lighting. The tower is elevated above the ground plane, creating a generous 2,500 square meter public plaza. This open space improves pedestrian experience along Park Avenue and encourages circulation towards nearby urban landmarks such as Grand Central Terminal. The plaza includes seating areas, landscaping, widened paths, making the urban environment more accessible and inviting. The design also respects New York's zoning vision for Midtown East by integrating the building into the city's broader mobility and public space strategy. The foundation represented one of the most complex engineering challenges of the project. The site is located directly above active train lines, subway tunnels, and critical transportation infrastructure. Because of this, the engineers applied the zero-load principle, meaning that the new tower could not place additional weight on the exact same foundation points as the previous 52-story building on the site. To solve this, engineers installed deep piles that extended down to Manhattan's bedrock, transferring loads to stable ground. At the same time, massive mega columns were strategically positioned to redistribute forces away from sensitive zones. This allowed the building to rise more than twice the height of its predecessor without compromising underground infrastructure. The structural system combines the lateral core with a network of perimeter mega columns, creating a strong and efficient load-bearing frame. The system enhances both the seismic and wind resistance of the building, which is essential for a super tall tower. The facade is composed of high-performance low-E glass, which reduces heat gain while maintaining natural light in the building. The finishes emphasize efficiency, daylighting, and environmental comfort while preserving a clean and modern aesthetic. The second project is the Zayed National Museum, which aims to honor the legacy of the founding father of the United Arab Emirates. Its design incorporates 5 soaring steel towers inspired by the wings of a falcon, a central cultural and national symbol of the UAE. These towers rise dramatically above the gallery spaces, creating an iconic silhouette visible from many points in Abu Dhabi. Beyond their symbolic role, the towers are fully integrated into the building's environmental strategy, functioning as thermal chimneys that enhance natural ventilation. The museum uses a smart passive design to reduce the need for air cooling in the desert climate. Hot air rises into the towers and releases outside, Meanwhile, while cooler air enters through the underground pipes that naturally reduce the temperature. Thanks to this system, the building saves a large amount of energy and stays comfortable for visitors. Building the museum required a special work on the foundation. Since the soil is sandy, engineers used a vibro compaction to make it denser and stronger. Then they install a deep rotary piles to support the weight of the galleries and the towers. Because the museum has many curved and angled shapes, the placement of the foundation had to be extremely precise. The structure of the museum uses both concrete and steel. Concrete supports the lower galleries, while steel shapes the tall wing-like towers. The complex forms of the building were designed using parametric tools to make sure that everything fit together correctly. All systems, air conditioning, electrical, and plumbing, were coordinated using beam technology so that they could be installed without interfering with the unique architecture. The interior design aims to create a peaceful and elegant atmosphere. The museum uses natural colors inspired by the desert and carefully controls daylight to protect the exhibitions. Lighting designer Claudia Eagle created a soft and well-balanced lighting system. In some spaces, like the auditorium, traditional emerald fabrics are used to absorb sound and light, adding both comfort and cultural identity.